Jeff, and welcome to Fun with Fluorine. Today I'm going to introduce you to the awesome element that is fluorine, and the many powers that fluorine possesses. What's the big deal about fluorine? Well, it's active, it's reactive, it's destructive, but it's also helpful in our daily lives, and you can find it almost anywhere. Fluorine was discovered in 1886 by a French chemist named Henri Moissan. He was the first one to isolate fluorine from its many compounds, and the process he used then is essentially the same way it is produced today. Fluorine can be found here on the periodic table under the halogens group. The atomic number of fluorine is 9, which is also the number of protons in the nucleus, which I've represented by these red balls inside the nucleus of the model. The atomic number 9 makes it the 9th element on the periodic table. The mass number of this specific type of fluorine is 19, which is calculated by adding the number of protons, the red balls, and to the number of neutrons, represented by the blue balls. Since there are 10 neutrons and 9 protons in the nucleus, the mass number is 19. The atomic mass of fluorine is 18.9984032, which is just short of 19. So why is it different? Because the atomic mass is the average mass number of all the isotopes in that element. The total number of electrons in fluorine is 9, which is the same number of protons. In fluorine, the electrons are contained in 2 different electron shells, shown here by the yellow lines on the model. The first shell can only contain 2 electrons, meaning the other 7 are in the outer shell. The electrons in the outer shell are called valence electrons. The number of electron shells helps locate the element on the periodic table. Since fluorine has 2 electron shells, it is located on the second row, or period, of the table, along with elements like carbon and oxygen. Because fluorine has 7 valence electrons, a lot can be determined about its properties. Having 7 valence electrons means you can find it in the 7th column in the periodic table, which is the halogen family, along with other elements like chlorine, bromine, and iodine. All elements in the halogen family have 7 valence electrons. Since it has 7 valence electrons and only needs 1 more electron to get to 8 to fill its outer shell, it will do almost anything to get it. So most of the time you find fluorine as a compound, which is bonded to other elements. In fact, fluorine is so desperate to complete its shell, it's capable of bonding with almost any other element except the noble gases. If you isolate fluorine, it has a pale yellow gas at room temperature, and it doesn't take very long to realize why the gas is so dangerous and destructive. Fluorine is perhaps the most reactive element on the periodic table due to the fact that its 7 valence electrons are so close to the nucleus. How reactive, you ask? Well, reactive enough that there's no way that my parents would allow me to show you inside their house. So here are a few examples. It's even used in the enrichment process of uranium, a compound called uranium hexafluoride used in the creation for fuel of nuclear reactors and nuclear weapons. Fluorine played a part in the first atomic bomb. But don't worry, fluorine gas isn't found naturally. Remember, it only needs 1 electron to fill that outer shell, so it bonds with almost any other element to form numerous compounds. Let's look at a couple. There are 2 types of bonding that fluorine can do, ionic and covalent. What causes bonding is the need for an element to fill its outer electron shell, which requires 8 electrons. In ionic bonding, the number of valence electrons that an element already has will determine whether it will lose or gain electrons. If an element has less than 4 electrons, then it will try to lose them, which will cause it to have a positive charge. If it has between 5 to 7 valence electrons, then it will try to gain electrons, which will cause it to have a negative charge. Here we have a sodium atom and a fluorine atom. Since sodium has 1 valence electron, it will get rid of it. Since fluorine has 7 valence electrons, it will gain the extra electron that sodium got rid of. Now sodium has a positive charge and fluorine has a negative charge. Because of the electromagnetic force, sodium and fluoride will be attracted to each other and form a bond. Covalent bonding is different in the sense that there isn't an even number of electrons that can be transferred amongst the other elements. The way that these elements form a covalent bond is by sharing electrons, so each one of the elements gets a full outer shell. Here we have a hydrogen atom and a fluorine atom. Since hydrogen only has 1 electron, it can't lose it, otherwise it wouldn't have any electrons. But fluorine also needs 1 more electron. They compensate by this by sharing 2 electrons with each other as shown, so that hydrogen has a full valence shell with 2 electrons, and fluorine has a full valence shell of 8 electrons. Now that I've shown the types of bonds fluorine can make, you may wonder what useful compounds it can make that are used in our everyday lives. Glad you asked! And with the help of my 2 lovely assistants, I'll show you. One of the ionic bonding examples I showed you was sodium fluoride, along with sodium monofluorophosphate, which are common anti-cavity compounds found in many toothpastes. It turns out when fluorine bonds with carbon, it creates a pretty non-stick surface that you can cook on. Teflon! Our water supply here in Marin County is fluorinated with a compound called hydrofluorosilicic acid. This is added to the water supply to help prevent tooth decay. And for you artists out there, hydrofluoric acid can be used as a tool to etch glass and make really cool designs in windows, drinking glasses, and jars. Now you know all about fluorine and its awesome properties and uses. It's been a gas. Fluorine can be a bit dangerous, but in the right doses and in the right compounds, it can be beneficial and protective as well. Thanks for watching Fun with Fluorine.